tutorial is about stacks. Now, what is a stack? Now, a stack is a linear data structure in which elements can only be inserted or deleted from the top. Now, let's take an example. Now, suppose this is a box, and if you want to add a box, then the box can only be added from the top. Now, if you want to add another box, then again it can only be added from the top. Now, if you want to delete a box, then the box can only be deleted from the top. The box can only be deleted from the top. And this is the reason why stack is also called last in first out data structure, LIFO. And in this example, this box at the top is the last one to get added. And now if you want to delete a box, then this box at the top, which was the last one to get added, will be the first one to get deleted. So last in, first out. Now, a stack can be implemented by using an array or a linked list. And this tutorial is about implementing stack using an array. Now, to implement stack using an array, first you need to declare an array. Now, this is an array named stack, which can store maximum 5 values. Now, to implement stack, you need to make this array behave like a stack. And you can do that by following some property of a stack. And that property of a stack is that an element can be inserted and deleted only from the top. Now, there's a variable called top, which is associated with a stack. And when the stack is empty, as you can see here, the stack contains no element. So the stack is empty, and when the stack is empty, the value of top is equal to -1. And this condition is also known as underflow condition. So when the value of top is equal to -1, then this condition is known as underflow condition, which means that the stack is empty. Now, if you want to insert an element into the stack, then the value of top is incremented by 1. Top equals to top plus 1. Now, the value of top at this point is -1. So -1 plus 1 equals to 0. So top becomes 0, and the new element will be inserted at this place. Now the value of top at this point is 0. This element is just a variable, and if the value of this variable element is 10, then 10 gets inserted at this position. So the new element 10 will get inserted here. Now if you want to insert another element into the stack, then again the value of top will be incremented by 1. And the value of top at this point is 0. So 0 plus 1 equals to 1. Now top becomes equal to 1, and the new element will be inserted here. So suppose the value of this variable element is 20, and the value of top at this moment is 1. So 20 will get inserted here. Now again, if you want to insert another element into the stack, then again the value of top will be incremented by 1. So 1 plus 1 equals to 2. Now top becomes equal to 2 and the new element will get inserted here. Now again you want to insert another element into the stack, then again the value of top will be incremented. So 2 plus 1 equals to 3. Top becomes equal to 3 and the new element will be inserted here, let's say 40. Now again if we want to insert another element into the stack, then again the value of top will be incremented by 1. So top becomes equal to 4 and let's say we inserted 55. Now you can see here that the stack is full. The stack has no space left to accommodate any new elements. So this condition, when the stack is full, is also called overflow condition. So when the stack is full, then it is also called overflow condition. Now when an element is deleted from the stack, then the value of top is decremented by 1. So top equals to top minus 1. Now the value of top at this point is equal to 4. Now if you want to delete an element from the stack, then the value of top will be decremented by 1. So 4 minus 1 equals to 3. So top becomes equal to 3 and this element will get deleted. Now if you want to delete another element from the stack, then again the value of top will be decremented by 1 and the value of top at this point is 3. So 3 minus 1 equals to 2. Top becomes equal to 2 and this element will get deleted. Now again if you want to delete another element from the stack, then again the value of top will be decremented by 1. So top becomes equal to 1 and this element will get deleted. So an element will always get deleted from the top, and this is how an element is deleted from the stack. Now here I have declared an array named stack, and max is the maximum size of the array. Now if the value of max is 5, then this statement is equal to this statement. Now both these statements mean the same thing, but this is the more appropriate way of declaring an array when you are making a program on stacks, because anytime you want to change the size of your stack, you just need to change the value of max. Now let's say I want to change the size of the stack from 5 to 15. So I'll just make this max 15 and the size of the stack has changed to 15. Now how to check for underflow condition. Now an underflow condition is when the stack is empty, and when the stack is empty the value of top is equal to minus 1. So you can use an if statement. If top equal to minus 1, then it means underflow. Now this statement will check is the value of top equal to minus 1, and if it is, then it means underflow. Now you can check for overflow condition by using this if statement. If top equal to max minus 1, then it means overflow. Now the size of the stack is 5, so this stack will be full when the value of top will be 4. And max minus 1 in this case, when the size of the stack is 5, means 5 minus 1, which is equal to 4. Now this if statement will check, is the value of top equal to max minus 1? The value of top at this point is 4, so 4 is equal to 4, and this condition becomes true. Top is equal to max minus 1, so it means overflow. Now let's say if the value of top is 3, and let's check this if statement. Now this if statement will check, is the value of top equal to max minus 1? Now the value of top at this point is 3, so this if statement will check, is top equal to max minus 1? And this condition becomes false because top is 3 and max minus 1 is 4, so this condition becomes false, and this is not an overflow condition. So this is how an overflow condition is checked. So in this video I just explained you the basics of stack. What is a stack, how an element is inserted into and deleted from a stack, how an overflow and underflow condition is checked. So in the next few videos I'll show you how to create a program on stacks. So that's all for now. Thanks for watching.